So today we're going to be talking about position time graphs, how to analyze them and turn them into velocity time graphs and acceleration time graphs. So as a student, I really struggled with this and I found it hard, and so did a lot of my friends. But I'm here and I think I've mastered it, and I'm going to teach you how to do it today. So every graph has a story behind it. So if I'm going to just tell you my story behind this graph. So let's say I was at my house, and that's this point. Here I'm walking away from my house. I'm going for a jog, and I realize I forgot something. So I'm standing still all the way to here, because you can see my position is in the same spot over the time. And then to get to here, I'm walking back to my house. Right here, I'm staying at my house, grabbed what I forgot, and I started to run all the way till I got to here, and I ran home. So now I've broken it up into 9 sections just to help us analyze it and see how this changes into a velocity time graph. In school, we learned that the velocity time graph is always the slope of the position time graph. So let's take a look at the first section. We have a straight line with a positive slope, which means that our velocity is going to have a positive constant velocity. So if we look at the second one, my position isn't changing over the time, which means we're not really moving. And how would we draw this? Is straight on the 0 axis. Okay, so for the third part, I now have a straight line with a negative slope, which means that our velocity is going to be a negative constant velocity. Why is this negative? Because we're slowing down, but just because we're moving in the opposite direction, which in my story means we're going back home. So the fourth part is pretty similar to the second part, and I've stopped at home, so I have a not moving and I have a 0 velocity. So now let's take a look at the fifth part. So this one looks a little different, and we have a curve. So if we were to draw that curve just to get a closer look and see how the slope is changing, if you choose 2 points on this line and draw 2 tangents to the line, we can see that this slope is steeper. This means that the velocity is increasing because the slope is increasing. And that will look something like this. Now the sixth part is pretty similar to the first part, and we have a straight line with a positive slope, which means that we're going to have a positive constant velocity. Now we've reached the seventh part, and this one looks a little different. If we take a closer look, we have a curve that looks like this. And if we draw our 2 points on this side, and our slopes, you can see that this one, the first point, is actually steeper. So this point is actually steeper, which means that it's slowing down. So our velocity, therefore, is slowing down, and we draw it right to here. And now this point, if we were to draw that slope, we have a horizontal line. And what's the slope of a horizontal line? Well, that's 0. So it's going to be like that. And then if we draw our next 2 points, we have a slope of this and a slope like that. And now this one's steeper, so it's increasing, although it's in a negative direction. So increasing in a negative direction looks like that, because the numbers get higher in the negative direction as you get lower. So now just remember that that 0 is only a point because your velocity is only 0 for this one split second. So once again, 8 is a straight line with a negative slope this time. So we're going to have a negative velocity, which is going to just be like this. Very similar to 6. So part 9, we have another curve, which looks just like this. If we draw 2 points, we have a slope here and a slope here. We can see that our slope is slowing down, which means that our velocity is slowing down. And slowing down in the negative direction means that it's going to go back to 0. So this was the story of how we changed a position time graph into a velocity time graph. Now we'll take a look at turning a velocity time graph into an acceleration time graph.